Okay, Papa 2 friends, today you're going to learn more about quadratic functions. Specifically, we're going to do vertex form and root form. So here's a lot of information you should read through and make sure you know. I'm going to go ahead and just start with the example. So, example 1. This is what we called vertex form, because it's up there, vertex form, so make sure you're familiar with it. We're going to go ahead and find the vertex of this equation. The vertex is always going to be h comma k. So let me write down the vertex form equation here. And like I said, if you read through the information above, you'll always know that the vertex is located at h comma k. So for this one, our vertex will be -6 comma -1. To find my y-intercept, you have to plug in 0 for x and solve for y. So go ahead and plug in 0 here for x and evaluate y equals 2 times 0 plus 6 squared minus 1. If you evaluate that, you'll get 71. And then our equation for the axis of symmetry, again, if you read the notes on top, it tells you it's always x equals h. So it's going to be x equals -6. And does this have a min or a max? So this parabola, when we graph it, it will open up because it has a positive a value. So that means it's going to have a min. And the min is going to happen at the y value of the vertex. So -1. The domain of all of the quadratic functions is going to be all real numbers. So we can just put -infinity to infinity, or you can just put all real numbers if you want. And the range, since I said it opens up, the range is going to be from -1 to infinity, or you can put y is greater than or equal to -1. And then the transformations that we need to know based on all the information at the top, make sure you read it. Because a is equal to 2, that means that there is a vertical stretch by 2. And then there is, because of the x plus 6, that means there is a horizontal shift to the left 6. And because of the -1, there is a vertical shift down 1. So now we're going to go ahead and apply all that so we can graph it. The first thing that I do for graphing is graph the vertex, -6 comma -1. Okay. And now there's different ways to graph a quadratic function. You can make a table of values if you wanted, like x comma y, and start plugging in numbers here to the right of the vertex and to the left of the vertex. Or you can use this thing called the counting pattern. So the counting pattern says that from the vertex, you can go over 1 and up 8 times 1. So here, that's from the vertex. And then you can go over 1, up 8, 3. So let me show you what that means. In this example, a was 2. So a was equal to 2. So what I'm going to do is, from the vertex, I'm going to go over 1 to the right, and then up 8 times 1. So that'll be 2 times 1, so up 2. And then from that point, so from this point, I'm going to go over 1 and up 3. So I'm going to go over 1 and up 8 times 3. So 2 times 3 is 6. 1, 2, 3, 4, 5, 6. And then I'm not going to be able to fit the 8 times 5. So then on this side, so that's going to be part of my parabola. On the other side of the vertex is just symmetrical. So I'm just going to put symmetrical and do it like that. So this first point was from the vertex, and this one was from the point, from the previous point. And that's how you can graph a parabola using the counting pattern. Make sure you practice those. Now, let's do the same kind of example except for example 2. We are going to do the same thing we just did, but the thing is that example 2, we need to change this equation into vertex form. So we need to change it into the ax minus h squared plus k. So in order for us to change this equation into vertex form, we need to do what's called completing the square. And the way that works is we're going to take our quadratic here, and what you do to complete the square is you look at the linear term. So this 6x is your linear term. You look at that linear term, you take the coefficient divided by 2 and square it. So I'm going to take this 6, I'm going to divide it by 2, and I'm going to square that, and that's going to give me what I need in order to complete the square. So let me try that. 6 divided by 2 is 3. 3 squared is 9. So then here's how I'm going to complete the square. I'm going to rewrite the question. Y equals x squared plus 6x. Okay, then right here I'm going to complete the square. So remember, 6 divided by 2 is 3. 3 squared is 9. So I'm going to add a 9 right there, and that's completing the square. Okay, then I'm going to keep writing the rest of the question. So plus 4. But because I just added the 9 to complete the square, I have changed the problem. Now I have that extra plus 9 there. So I need to subtract 9, so I need to undo that. Minus 9 will cancel this plus 9 so that I can keep the equation equivalent. So I've completed the square, I've kept my equation balanced by subtracting the 9, and now I can change it to vertex form by taking this perfect square trinomial, x squared plus 6x plus 9, and factoring it. That's going to be x plus 3 squared, because that gives you x squared plus 6x plus 9. And then the positive 4 minus 9 is going to give you a minus 5. And now I have changed my equation to vertex form, and you can answer the rest of that information. Okay, so now that I have completed the square here, you should be able to answer all this information just like I did on example 1. So go ahead and pause the video now so that you can answer all this and graph. Okay, hopefully you tried it, and here's what the answers you should have gotten. Vertex form, or clearly, I just need to write down the vertex form. The vertex is going to be at -3, -5. Axis of symmetry, x equals -3. The parabola still opens up, so it's a min of -5. The x-intercepts, okay, so that one I didn't do on example 1, so let me show you. So for the x-intercepts, that's when you plug in 0 for y and you solve for x. So I'm going to plug in 0 for y over here and solve for x. In order to solve for x, I'm going to add 5 to both sides. 5 equals x plus 3 squared. In order for me to cancel this square, I need to take the square root of both sides of this equation. So I end up with the square root of 5 equals, okay, you have to be very careful when you do the square root of x plus 3 squared. That comes out to be absolute value of x plus 3. If you don't put absolute values there, you're going to get points off, and it's not going to be correct. So remember, this is the even, odd rule. You just take the square root of an even power, and then your answer comes out to be x plus 3 to the first power. So that needs absolute value. And now I can get rid of my absolute value by doing x plus 3 equals just plus or minus the square root of 5. And you can write it like that, because it will be positive square root of 5 and negative square root of 5. So finally, to solve for x, I'm going to subtract 3. So x equals -3 plus or minus the square root of 5. And that's my x-intercept, -3 plus or minus the square root of 5. The y-intercept is just when x is 0. So when you plug in x equals 0, you get a y-intercept of 4. And finally, the range was from -5 to infinity. And when you graph it, I'm going to graph -3, -5. My a value is equal to 1. So from the vertex, I'm going to go to the right one and up 8 times 1, which is just 1. And now from that point, I'm going to go to the over 1 and up 8 times 3. So 1, 2, 3. And from this point, I'm going to go over 1 and up 8 times 5. So 1 times 5, 1, 2, 3, 4, 5. And that's the right y-intercept. Connect. The left side of the vertex should just be symmetrical. So you can just graph it symmetrical. And that's how you graph that parabola. So now let's practice 3, 4, and 5. Let's practice completing the square when your coefficient of x squared isn't 1. So like this one here, 3x squared. Here's what we're going to do. In order for you to complete the square, the coefficient of x squared has to be 1. Like it was on example 2, it has to be 1. So in this case, since it isn't 1, I'm going to factor that 3 out. So I'm going to write it as y equals 3 parentheses x squared minus 10x, close the parentheses. I'm going to leave a little room there because I'm going to complete the square, plus 71. So notice how I only factor the 3 out of the terms with an x. So 3x squared minus 30x were divided by 3. So I wrote it as 3 parentheses x squared minus 10x. And then the plus 71 is just going to stay at plus 71. Just leave it alone. So now that my coefficient of x squared is 1, I can complete the square. Here's how you complete the square. Just like I did on example 2. You take the coefficient here of your linear term. So this 10, or you can think of it as minus 10, either way. You take 10 divided by 2 and you square it. That's how you complete a square. 10 divided by 2 and square. So let me go ahead and, I guess I should just complete the square right here. 10 divided by 2 is 5, and 5 squared is 25. So I'm going to put plus 25. Even if you left it as negative 10 divided by 2, that's negative 5, and when you square a negative 5, it's still plus 25. So there it is, plus 25. Okay, now you have to be very careful when you balance this out. So remember, I just added like a 25 there, so I need to balance this equation out. However, it looks like I added just the plus 25, but because there was a coefficient of 3, I have actually added a 75, because you have to multiply positive 25 times 3. That's a 75. So in order for me to keep the equation balanced, I need to cancel the adding of a 75 with subtracting 75. So now I have completed the square, and I have kept the equation balanced by subtracting 75. So I can do my factoring now. X squared minus 5x plus 25 is just going to factor as x minus 5 squared. And then 71 minus 75 is negative 71. So that's how I completed the square. And you need to practice those. So let's try it again with number 4. The problem with number 4 is that your coefficient of x squared has to be a positive 1 x squared for you to complete the square. If it's not, we're going to have to factor that out. So let's do y equals negative x squared plus 4x plus 3. So again, I just took the negative out of the terms with an x and wrote it as negative parentheses x squared plus 4x. The positive 3 can just stay a positive 3. So the way you complete the square, you take your linear term. So the coefficient of your linear term is 4. You divide it by 2 and you square it. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add a 4 here to complete the square. Done. And you need to keep the equation balanced. So it looks like I'm adding a 4, but remember, you have to multiply that by your coefficient in front of the parentheses. So you're actually doing a minus 4 right now. That's a minus 4. So if you want to keep the equation balanced, to cancel a minus 4, you actually have to add 4 to keep the equation balanced. So now I can just do my factoring. X squared plus 4x plus 4 factors into x plus 2 squared. And then 3 plus 4 is 7. So that's how you complete the square. Try it one more time now with example 5. It has a 1/2 x squared. So pause the video, try to do example 5 by yourself by correctly factoring the 1/2 out of the 2 terms with an x, and try to complete the square by yourself. Okay, I hope you paused the video and actually tried it by yourself. If not, here it goes. 1/2 x squared. I'm going to factor that out. 1/2 parentheses x squared minus 12x plus 15, because negative 12x times 1/2 is negative 6. If I complete the square, you take the linear term, 12 divided by 2, and square that. So 12 divided by 2 is 6. 6 squared is 36. So I'm completing the square. In order for you to keep the equation balanced, you need to cancel out what you added. However, we didn't really add a 36. We have to multiply by half. We actually only added an 18 because 36 times a half is 18. So then we need to keep the equation balanced by subtracting 18. So number 5, your answer should be y equals 1/2 x minus 6 squared, and then 15 minus 18 is -3. And make sure you practice completing the square. And then the next type of equation that you need to be familiar with is called the root form. So far we just focus on vertex form. Right now we're going to now do root form, and then you still have to watch the other video on standard form. Right, so root form. I guess let me write it down over here. It's y equals a x minus root 1 times x minus root 2. Root 1, root 2, those are the roots, which are also known as the x-intercepts. All right, so number 6, given this equation, I need you to find all the information. So here's the best way to do this one. The best way to do this is to first find those roots, which are going to be your x-intercepts. So my first root, based on the equation, is going to be a -1, and my second root, based on this equation, is going to be a 7. So those are called the x-intercepts. So let me write those down. -1, 0, 7, 0. I guess I might as well graph them. -1, 0, 7, 0. Okay, so because you have the x-intercepts, those are going to help you find the axis of symmetry. Like if you find the midpoint between those two x-intercepts, it's going to help you find your axis of symmetry. So that's what I'm going to do. I'm going to find, I guess, the axis of symmetry, or in other words, I'm going to find the h value of the vertex, which is somewhere here on the axis of symmetry. So I'm going to go ahead and put h, which is the x value of the vertex, equals the midpoint between your roots. -1 plus 7 divided by 2. So that's going to give me 3. So that's my axis of symmetry. Okay, I'm back. My computer got locked. All right, so h equals 3 is the axis of symmetry, and that is the x value of your vertex because I found the midpoint. So we know that the vertex is somewhere at 3 comma something. And to find the y value of the vertex, I'm going to go to my equation, and I'm going to plug in the x equals 3, the h value here for x, so that you can find the y value of the vertex. So we know that the y values are equal to 1/2 x plus 1. So if x is 3, which is the x value of the vertex, I'm going to do 3 plus 1. And then x minus 7, so I'm going to do 3 minus 7. If you evaluate that, that's going to give you the y value, which is -8. The y value that goes with x equals 3. So therefore, if the vertex is at x equals 3, then the y value of the vertex would be at y equals -8. So now I have that and I can graph it, 3, -8. And y-intercept, just like every other y-intercept, to find the y-intercept, plug in 0 for x. So y equals 1/2, 0 plus 1, 0 minus 7. Multiply that out, simplify it, and you get -7/2. So 0 comma -7/2. And the range was just going to be from -8 to infinity because it opens up. And this has a minimum value of -8. And we can just do those 3 points. That's enough to graph. You just need the vertex and then 2 other points. So that's how you would use root form to find out all the information. Obviously, you need to practice these. And finally, so now you need to write the equation in vertex form that describes these graphs. So remember, vertex form is y equals a x minus h squared plus k. So in order to write the equation, the very first thing you're going to need is you're going to need to find the vertex so you can plug in the h and k. So let's do example 7. That has a vertex at -2, -6. So that means that I'm going to write y equals a. I'm not sure what the a value is for now, but I'll just put a. X minus h. So h is -2, so I'm going to put +2 squared. And then plus k. K is -6. So I've plugged in the vertex for h comma k. And now I need to solve for the a value. So the best way to solve for the a value, some of y'all can use like the counting pattern and figure it out in your head. But the best way to solve for the a value is to actually plug in one of the other points that are given for x and y so that you can actually solve for a algebraically. So for example, let's say I plug in this point here. What is this point? 1, 6. So I'm going to plug in 1 for x, and I'm going to plug in 6 for y, and I'm going to solve for a. So I plugged in 1 for x, 6 for y, because that was the point. And then I'm just going to do some algebra here to solve for a. 12 equals a. 1 plus 3. 1 plus 2 is 3. 3 squared is 9. So then if I divide by 9, a equals 12 over 9. Make sure you reduce 4 over 3. So my final answer for number 7 is going to be y equals 4/3 x plus 2 squared minus 6. Now you should pause the video and try example 8 by yourself, just the same way I did on number 7. Okay, I hope you did number 8 and got the answer to be y equals -1/2 x minus 4 squared plus 7 because the vertex was at 4, 7, so that's how I got the h and k. And then if you were to plug in either one of the points given, I plugged in 0, -1. Here's my work. I plugged in 0, -1. I did get that a was -1/2. So now you need to go and practice this and watch the standard form video.